Hi everyone, Dusty from Discovery Lab in Tulsa, Oklahoma for Discover at Home, a series of experiments and activities that you guys can do at home with a parent or caregiver. Today's experiment is Scribblebots, where we'll be learning about circuitry and balanced and unbalanced forces. We've partnered with the Opportunity Project to make these kits so you can have all the supplies that you need to perform this experiment. However, if you don't have the kit, you can make do with what you have at home. Inside the kit, you'll find step-by-step instructions for doing this experiment, a sketchbook for your robot to draw in, markers, a plastic cup with a large rubber band around it, a motor, a AA battery with another smaller rubber band wrapped around it, a very tiny rubber band by itself, a binder clip, tape, and googly eyes to decorate your robot. Before we get started with our project, let's talk a little bit about electricity. What do you guys know about it? How do we make electricity? How does electricity get to our homes? What is electricity made out of? I bet you guys have a lot of answers for those questions. Let's go over them. Electricity is a form of energy that we can use to power devices, turn on lights, and do work around our houses. We can create electricity a lot of different ways. We can convert solar energy from the sun using solar panels. We could use wind power by using wind turbines, or water through hydroelectric to convert that energy into electrical energy. We store energy a lot of different ways. Generally, we store them in batteries, so that way the electrical energy can be used later. We also transport energy from plants where it's made to our homes using wires. It comes out through an electrical outlet, which we can plug into, and we harness that energy. But why does electricity work the way it does? That's where we get to the fun part. To talk about that, we have to talk about atoms. How many of y'all know what an atom is? An atom is the smallest piece of an element. So for instance, if I had a big ball full of helium, the smallest piece of helium I could get would be one atom of helium. I could get an atom of a lot of different things. I could get an atom of oxygen. I could get an atom of gold or of silver. But that atom has a lot of fun properties. It's made up of three things: protons, neutrons, and electrons. Which one do you think is the most important for electricity? Electrons, that's right. If you took a look at the atom, it'd look a bit like an egg, with the center of protons and neutrons. Then it has a shell. On that shell is where electrons live. However, they aren't stuck in one place like protons and neutrons are. They can move all around in a cloud. As they spin around, this is how we utilize electrical power. These electrons are able to move or jump from atom to atom because of different charges. How many of you guys have played with magnets before? If you take two magnets that have the same charge and push them together, they'll want to push apart. However, if you have two that are opposite or different and bring them close by, they'll want to attract. Similarly, we can have charges with atoms. If you take a look at a battery, you'll notice one side has a plus or positive side. The other is a minus or negative. This shows the different charges. We have positive and negative. Because electrons can jump from atom to atom, they change the charge of the atom that they're in. If there's a bunch of electrons on an atom, we say it has a negative charge. However, if an atom has lost all of its electrons, we say it has a positive charge. the negatively charged atoms want to be attracted to the positively charged atoms. They jump and pull these electrons closer to them. Certain elements allow this a little bit easier than other ones. For instance, copper, gold, and silver are very good conductors. They let electricity flow very easily. Other things like plastic and rubber don't let electricity flow as easily. They stop or resist the flow of electricity. We call these non-conductors. Now, if you've ever reached out and touched a doorknob and got a little shock, you know electricity can hurt sometimes. That's why we want to use non-conductors and conductors the right way, so electricity only goes where we want it to. Otherwise, it could damage us. That's why if you take a look at a motor, you can see that the wires are coated with a plastic or rubber coating. Only a small amount of the metal sticks out. The metal is going to conduct the electricity. The plastic is going to prevent electricity from going outside of where we want it to go. Similarly, a battery has two metal ends. We have a plastic wrap around it to keep the electricity from flowing where we don't want it to. Whenever we can connect both ends of a battery, we can create what's called a circuit. Electricity flows in a circular pattern. If I take my motor and I touch this end to the negative side and this end to the positive side, my battery begins to power up my motor and it spins around. But as soon as I break or open my circuit, it stops. If you take a look at this guy right here, this is just like my battery. I have two metal ends, then plastic in between to keep electricity from flowing between the two until I make that circuit or circle shape to let it flow through. So if I grab this end here and this end here, you can see that electricity flows and it lights up the lights inside my stick. My arms create a circuit as it flows up and around and then back. You may be thinking, doesn't this hurt? Believe it or not, electricity isn't going through me. Electricity is actually traveling around me. Because we measure electricity in a lot of different ways, it has a lot of different properties. In this case, my battery is so small that it doesn't create enough electricity to actually go through my skin and zap me. However, because these lights don't require a lot of electricity, only a small charge needs to be able to travel. This charge is able to travel on the moisture in my skin. So when I touch this end and this end, it travels through the sweat on my skin until it reaches all the way back, creating that circuit. Well, I hope you guys are ready to start building now. Let's get started building our Scribble bot. Grab your robot body, the cup that has the rubber band around it, and your markers. We're going to give our robot some legs. To do that, stick the markers through the rubber band. Make sure they stick out pretty far from your cup. Now, if you'll notice, I've only got 3 markers. You could use more if you wanted to, but make sure you use at least 3 so your robot balances well. Let's make sure it's well balanced. Looks pretty good to me. You can see that my legs all face the same way, and I can push it around and it doesn't fall over. This showed me that my body has a good balance. Now, let's talk about our motor. You notice your motor has 2 wires coming off of it, a black one and a red one. Normally, whenever we are attaching motors, we would want to attach the black wire to the negative side of the battery and the red wire to the positive side of the battery. In this case, it doesn't matter. Our motor will spin clockwise if we hook it up one way and counterclockwise if we hook it up the other way. Your battery has a rubber band around it. Leave it on. It's there for a reason. If you've ever looked inside a remote control, you've seen little metal springs that push up against the ends of your battery. They help create a good circuit. They press to make certain the metal doesn't ever come out of contact, so the electricity can flow. That's what the rubber band does. It's going to squeeze the tips together So that way, the metal tips at the end of the wires for your motor are always in contact with the metal tips at the end of your battery. Let's put it on our body. I've got a nice long piece of tape. I'm going to lay it right across the silver part of my robot body. Whenever I'm attaching my motor, I want to stick it as close to the edge as possible, because whenever I add my propeller or wobbler to the end, I don't want it to hit my robot body. It's going to be moving quite a bit. Looks good. Now I want to do the same thing with my battery. I'm going to turn it perpendicular. See how my tape goes one way and then my battery goes the opposite? It makes a straight corner right there, like the corners of a square. This is called a perpendicular angle. Tape that into place where it's close to your motor, close enough that your wires can reach it. All right, he's on there good and snug. Let's make certain that I've got the wires working well. So I'll plug in this side and then this side. And it sounds like I've got power. That means that my motor's going to work. Now let's attach our propeller or wobbler. This right here is what's going to give us our unbalanced force. If you've ever seen a fan that has one blade that's just a little off, you know it starts rocking and wobbling an awful lot. We're going to take that rocking, wobbling motion from that unbalanced spin to make our robot move. You notice when I plugged it in first, it just stayed there and kind of buzzed. That's because all the energy turning the spindle was balanced. It spins with no problem. We're actually going to make it a little bit harder for it to spin so we can get a lot of good energy. Grab your little bitty rubber band and your binder clip. The rubber band is going to give us a good grip so that our binder clip doesn't fly off. If you find that it's loose or it falls off, just tighten it up and put it back on again. It's all right. Make a little loop with your rubber band and set it on the end of the spindle of your motor. Then, using your binder clip so that way you get a good bite on that rubber and the spindle. So that way I've got a good solid hold on it, so it's not going to fly off. All right, I think this guy is about ready to test. So I'm going to grab myself a blank sheet of paper, set it down, pop the lids off my markers, put my robot onto my paper, and then I'm going to plug it in. We're going to see what my robot draws. If you have the instruction sheet, guess what you think this robot's going to draw before you plug it in. Then test it out and see what it draws inside that area. All right. My robot's wiggling and wobbling. However, it's a little bit too balanced. It's spinning like a fan. I don't have a lot of wobble. That means I need to make an adjustment. I'm going to break that circuit or unplug it. I want it to be even more crazy. That was too good. I need to make it spin worse, which sounds like a bad thing, but not in this case. So I'm going to take it and I'm going to pinch it and I'm going to move it close to the edge. So that way, instead of being right in the middle, it hangs off a little to one side. Let's see if that helped me move. There we go. Oh, he's moving so good now. Oh, it went off the paper. Maybe I should use the bigger paper. And he's coming back around. All right, let him finish that drawing. And break the circuit and unplug it. Let's see what he drew. A masterpiece if I ever saw one. You guys noticed I had to make some small adjustments. Don't worry if you guys have to make similar small adjustments when creating your Scribblebot. That's part of inventing, is finding what little things you can do to make it better. I bet I could change the way this wobbler or propeller spins to make them make different shapes. Also, I wonder what happened if I plugged in my wires to the opposite side. Remember how I said it'd work either way? It'll spin one way if you plug it in one way, and the other way if we don't. I'm excited to see how you guys create your Scribblebots. I want to see some unique inventions, and I'm excited to hear from you guys to see what you all made. Hopefully you guys all have created a successful Scribblebot. I'm looking forward to hearing about it on our Zoom call later. What were the biggest problems you had? What was the best part about building this? How do you think you're going to make it different if you made it again? I want to hear all those questions and other ones that you guys have. That's going to do it for our Scribblebots engineering project. Hopefully you guys have had a lot of fun learning about circuitry and balanced and unbalanced forces, and you've created a successful Scribblebot. I've been Mr. Dust. Thanks for hanging out with us, guys. We'll see you next time.